Hello, this is Greg Bixler, and I'm a co-founder and CEO of Design Outreach. We're a Christian humanitarian engineering nonprofit organization based in Ohio in the United States. We aspire to be the go-to innovation solutions provider for global partners combating poverty. And today I get to talk about creating a new hand pump solution in Africa. This all started about 10 years ago when we first started learning about the water crisis and the lack of safe water for the majority of the world. And so, after reading all of the journal articles and talking to missionaries and interviewing NGOs, we decided to go to Africa and see the problem firsthand ourselves and discover what we couldn't learn without going. One of the issues that we discovered was that there's just a lack of water all around. So, in order to filter water or chlorinate water or boil water, it really doesn't work because there's not enough volume to work with. We visited a community in Malawi where we asked the community to take us back to where they were getting water. And they led us back to this watering hole, which is about 3 feet in diameter and maybe 6 inches deep. And this water is barely enough volume in order to drink for a village of 300 people, let alone washing or using for a garden, for instance. To make matters worse, this water is highly contaminated. And even if there's a large body of water, like as shown in this picture in a village that we visited in Ethiopia, the water is highly contaminated yet because there's cattle walking through the water. And this is water that this girl was about to drink. And then there's the amount of time and effort that goes into carrying this contaminated water. We met this girl in Malawi. She has her school uniform on. And instead of learning how to read and write and do arithmetic, she's learning how to carry water at a very early age, because this is what she's going to do for most of her life. And in fact, the village where we found her, the women were spending about 12 hours a day just getting water. And as a mechanical engineer, I was very interested in the pumps themselves. We found these girls using this pump in Haiti, and the one girl is jumping off the ground, pushing her entire body weight down on the handle in order to get just a trickle of water. This is very hard work for very little water. One of the things that surprised us was the depth issue. We had heard that water pumps weren't able to go deep enough to reach the water, but we never realized how widespread this was. And in fact, in some places, up to a third of the time that drilling is done, water is not found within the range of the standard pumps like the India Mark II or the Afrodev. And when that happens, when the water is deeper than, say, 45 or 50 meters, the drilling operation has to stop, and the community is massively disappointed. Let alone it costs thousands of dollars just to have that dry borehole drilled. The pumps are designed to be inexpensive, and because of that, they're unable to last very long, as we discovered. We discovered about 345,000 of these pumps have been installed, and yet 125,000 are no longer functioning in just sub-Saharan Africa alone. This was really surprising to us as we've driven around in a lot of developing countries and we see a lot of broken pumps. One of the main reasons these pumps are breaking is because they were just designed to be inexpensive. And even though the parts that might have broken were inexpensive, there's not a good supply chain. And so to get parts out to the community might cost hundreds of dollars just to drive it out to the community. And in many cases, these pumps only last on average of 6 months before they break. In some places, only a few weeks. And on average, it takes about 30 days to get the pumps fixed. And so that means people have to do without good water for 30 days at a time or longer. And this is very unacceptable. This problem is widespread. RWSN did a study in 2009 showing that in some countries in sub-Saharan Africa, up to 65 or 67% of the time these pumps are broken. And this is widespread across all these different countries. There's many reasons that have led to this problem. One of the primary reasons are low yield, poor water quality, and mechanical failure. And these are really interrelated to one another. They're not mutually exclusive. For instance, the low yield is because the pumps are hard to use. They're not designed to go deep. The poor water quality contributes to mechanical failure because of material selections like galvanized steel, which do not hold up well in certain pH water. And then mechanical failure, the pumps are just designed to be inexpensive, and so therefore the components are not stainless steel or corrosion resistant, and they're not heavy duty to withstand the rigors of daily use. In order to solve this problem, Design Outreach came together really as a coalition of partners. We We have about 75 volunteers and about 12 partner organizations who said we can do something about this, we can solve this problem. And we really wanted to pull in the world's experts in different areas like academia, industry, nonprofits, and donors, where each holds a certain skill set. For instance, academia, great research base; industry, great manufacturing and scalability; nonprofits, boots on the ground and knowledge of the problems. And of course, donors like Rotary, who want to see their money leveraged in even bigger ways and have real impact. But we wanted to pull the expertise from each of these areas in such that we could solve the problems and not just create another band-aid solution. In our research, we came across a pump that was developed in the 1970s and was used through the 1980s. And this pump is called the Moino hand pump, made by a company named Robbins and Meyer based in Ohio. And this pump was actually quite popular. About 6,000 of these pumps were produced, but then they were discontinued in the mid-1980s because UNICEF subsidized the India Mark II and Moino basically went out of business. Some of these pumps are still actually on operation today, even though spare parts haven't been made since the 1980s. And this is very inspirational to us because we wondered, how is that possible when the other pumps only last, say, 6 months at a time and then break? And we learned that this is based on a progressive cavity pump design, which is very durable and doesn't rely on O-rings or valves in order to operate. And in fact, it can withstand a lot of abuse before it quits pumping water. We took that as inspiration and added in 30-year newer materials, durable components using things like stainless steel, and developed what we call the Life Pump. The Life Pump is a hand pump that goes down to 100 meters based on the progressive cavity design. That's over twice the depth as an Afrodev and India Mark II, which even at their maximum depths are very hard to operate and tend to have even a shorter life. The Life Pump at 100 meters can be operated even by kids and get about 2.5 gallons per minute, which is a high flow rate at that depth. We're very excited about this as we're also developing a 150 meter deep well pump, which is going to be tested soon in Haiti. Our first prototype was built in 2011 and we took it to the Central African Republic, working with a partner called Water for Good, where we did our first installation and discovered that this was a great learning experience, which in engineering is code for it didn't work. We discovered that the pipes and the thread form that we had anticipated were different than what we were using as our testing in the United States, and so the pump actually unwound during testing and was something that we came back and retooled and fixed for future versions. In that process, we decided to drill our own test well in Ohio and do ongoing testing so that we could anticipate failures before we see them in the field. This included developing a research and development lab where currently we're doing ongoing life testing of wearing components and critical parts in order to see when and how many cycles something might fail at before it ever happens in a community in the field. Our first permanent installations were done with World Vision in 2013. These were in communities where the water was too deep for the standard Afrodev, and so World Vision asked that we send a couple pumps. They drilled down to about 70 meters, they put in the life pumps, and instantly started to get water. World Vision was very impressed, and so were the communities, of course. And so we were invited to start what we called the 100 Pump Project, which is a 5-country pilot program with World Vision, as well as local partners like Ministries of Water in the various countries. We started in Malawi, we went to Zambia, Kenya, Ethiopia, and then last Mali. This has been very successful. We've reported on our successes and have gotten a lot of good attention by the world's NGOs as well as Ministries of Water. Just a few pictures here from Malawi. This is our Life Pump Engineering Director getting splashed by this kid. In Zambia, Kenya, Ethiopia, and Mali. We also started a partnership in Haiti with a different NGO. And as you can see here, the base looks very different. This is actually an India Mark II base that we redesigned our pump to fit on top of so that retrofits can be very simple and not have to tear out the India Mark II base out of the concrete in order to do a retrofit. This was a case where an India Mark II was installed, it was breaking down frequently, it was hard to use, and so we replaced it with a life pump here. You've probably also noticed the funny spouts that are on some of these pumps. These are actually satellite-based remote monitors. We're very excited to be working with an organization called Sunset Solutions based out of Indiana in the United States. And this allows us to monitor pumps in real time via the web over a satellite link in order to see how much the pump's being used. As sort of a check engine light, this is the kind of data that we can gather. These are gallons per day over a certain period of time from a couple different villages where we have life pumps. And this can really show us pumping behaviors and patterns to know from a maintenance perspective when things should be maintained to do preventative maintenance and not a repair. We're also very enthusiastic about the pumping performance over time so that the pumping efficiency doesn't change. As you can see in our first year of operation in a couple of villages in Malawi, the pumping performance stayed very, very similar as far as volumetric efficiency. This has to do with a number of handle rotations it takes to fill a 5-gallon bucket. And over time, you would expect more rotations necessary in order to fill the 5-gallon bucket as the pump wears. And this is one of the very nice features of a progressive cavity pump, where you don't see sudden failures. You see a very gradual, slow degradation of efficiency, which means that more rotations will be needed for the same amount of volume. And it allows communities to do preventative maintenance without ever having a catastrophic failure and the pump suddenly quit working. The value proposition of Life Pump really boils down to the reach to 100 meters as well as the 5-year maintenance interval cycle. With the 100-meter reach, this means that fewer dry boreholes will be drilled. Every borehole that's drilled, whether they hit water or not, costs thousands of dollars. And this also saves tremendous community disappointment by not having communities that were promised to have a water pump and suddenly being told that that wasn't possible. The 5-year maintenance interval saves the community a significant amount of money, which means that they can spend the money on other important things. It also provides them a consistent supply of water year-round, so now they can depend on this and plant gardens, for instance, and they can maintain their economic and health benefits that are shown from safe water supplies. There's about 80% less maintenance cost of Life Pump compared to an India Mark II or an Afrodev, and this translates into literally hundreds of dollars a year in savings, and in a very short time, more than pays for the Life Pump initial higher installation cost. The depth advantage is significant as well. There's a couple pumps that claim to go to about the same depth as Life Pump, for instance the Blue Pump or the Vernier HPV 100. However, our field experience and experiences of our partners have shown that these pumps are difficult to use and they break down more frequently as well at these deeper depths. And so we really are the only pump that can be used by kids on a consistent basis and have this kind of maintenance interval and life expectancy. Our longest running pumps to date were installed originally in November 2013, and there hasn't been any maintenance or repairs done to that, and that's over 3 years of runtime of daily use. We also have a significant cost advantage. The Life Pump is more expensive up front because of the high quality components and the stainless steel. However, because of the depth, if the Life Pump is used in locations where the water is too deep for an Afrodev, as in about a third of the cases in a place like Malawi, we actually save money per beneficiary because we have many fewer boreholes being drilled. And remember, each borehole costs thousands of dollars, whether water is hit or not. And this is also not directly looking at the human impact advantage, because every life counts, every person matters. Even if someone lives in a community where the water is deeper, it's very important that we're able to help and reach every community that needs water. One thing that I've heard often is that people in developing countries are just more immune to waterborne disease and they can drink bad water more often. And this has really bothered me over the years. And so I finally found a doctor who turned cultural anthropologist and asked him, is it true that people in developing countries can drink bad water and not be sick? And he said, that's not true, that's false. And in fact, they're just as sick as we would be. However, they don't realize they're sick because they've had constant diarrhea, for instance, their entire lives. And they don't realize that life expectancy should be more than 45 years old. And so I challenged one of my volunteers to do some research and find some peer-reviewed journal articles that would describe what happens when you drink bad water for how long. And so we found a report that was done in 2012, and it says potential health gains are reduced sharply, even occasional consumption of untreated drinking water, which is something that most of us would expect. We took the data from this report and we applied some probability and statistics analysis to this and found that within 5 days, somebody has a 60% chance of getting sick. And this is really astounding because remember, 30 days is the average repair time. And in some cases where NGOs claim to have very, very fast repair times, where we call them the ambulance repair, they're saying that they're really getting out there within 5 to 7 days and getting that pump fixed. But this report is showing that within 5 to 7 days, most of the village is sick. The people who are not sick are taking care of the people who are sick. The people who are in school, like the kids, they're being pulled out of school to go get the water. If someone had a garden, it probably has died by now. And so all of the positive benefits that have been gained are basically erased. And so we're really saying that having a pump that has any more than 1 day downtime is really not acceptable. And as we're always looking at the before and after, this is always such a stark comparison as I think about having my own 3 kids who are under the age of 7 and thinking about this could be them and the water that I would want them to drink versus the water that these kids are drinking. And so we're really excited about the future of Life Pump. We're now in 6 different countries. We have enough pumps for about 24,000 people out there. We're expecting to get pumps to 2.5 million people by year 2030. And that's with the help of partners like Rotary. We're building supply chains in a variety of countries right now, including Zambia and Malawi, as well as furthering partnerships in Kenya and Haiti. And so we're very excited about the future and the number of people that we're going to be able to permanently help for a very long time. And so I appreciate you paying attention and watching my talk today. And I'd be happy to field any questions. Please feel free to contact us at Design Outreach. Thanks so much.